Right, so this video will cover final exam questions that come from Chapter 2. All right, so the next problem that you're going to come across, and by the way, we're in Chapter 2 now, dealing with linear equations in two variables, right? All right, so notice it does, when in the practice test, it'll say to complete the table, which we're going to do here. And then it says the graph. So like in the practice test, it'll actually have you graph it. But like on the final exam, it's just going to have you complete the table. But just so you're aware of that. So the idea here is we're given a value of x here, and we need to find the y. So basically, we just take this value of x and plug it into our equation to get our y out. And kind of the way I like to do this, I got on the side here, I do this right here. So negative 2 plus 3, just plugging in the x there, is 1. So 1 would be associated with negative 2. Then we plug in the negative 1 for x here. So negative 1 plus 3 is 2. Then we would plug in the 0 for x here. And that would give us 3. Just completing the table here. Then we would plug in the 1 for x here. And we would get 4. Then we would plug in the 2 for x here. And we would get 5. So just got to complete the table there. Plug in your value of x to find your y there. All right, so the next one here out of Chapter 2 is just going to ask us to find slope. By the way, on the practice quiz, it'll ask you this additional part B question about does the point rise, decrease, or horizontal or vertical. Yeah, that's not going to be on the final exam, but it is in there in the practice, the online practice test, by the way. But anyway, what we really want to do here is find slope. So, just a reminder, remember our slope formula indicated by the letter m is y2 minus y1 over x2 minus x1, right? Remember, the more important thing is to keep all these things lined up, right? And like I said before, I like to say, okay, I'm going to grab this one minus this one over this one minus that one there. All right. That's one way I like to think about it. But let's go ahead and work this out. So we got the slope equals, so we're going to grab that 13 there. 13 minus negative 8 over, then we're going to grab that negative 10 minus negative 17. All right. Notice I put the negative values in parentheses there to be sure to indicate or be sure to remind myself that I'm going to have to change those positive, because negative minus a negative is a positive, minus a negative is a positive, right? All right, so we're going to include that in our next step. So we would have 13 plus 8 over negative 10 plus 17. And by the way, just to reiterate, notice one thing you can always do when you're thinking about slope is make sure that your corresponding y's are over their corresponding x. So we could check this, and we'll notice that 13 is over its corresponding x, negative 10, and negative 8 is over its corresponding x, negative 17. So just a check there as you're working through this. And remember, y is on top. Y is on top. Right? Remember these concepts, because calculating slope is really not that hard. But usually where things go wrong is keeping these lined up. And a lot of times people will put the x's, the x coordinates on top. So those are just a few common mistakes that I like to reiterate to remind you as you're doing this, because you don't want to miss this problem. It's really not that difficult. But anyway, so 13 plus 8 is 21. And negative 10 plus 17 is 7. And 21 divided by 7 is 3. Okay, so there's our slope. All right, so this next one here. So if you look up here in our objective, we're going to use slopes to determine whether two lines are parallel, perpendicular, or neither. All right, and then I'm just going to work whatever random particular problem that the computer has given me. But basically, there are three cases. There's a case of parallel, there's a case of perpendicular, and then there's also a case of neither. All right. If you want to further explore this concept, because on the test you could end up with any of these three cases, right? But to explore it further, there's already a video in the Canvas course that you can review, and then in that video I take you through how each one of these cases would look. So review that, but in just this one, I'm just going to work this one, the random problem that the computer gave me. All right, so let's go into the Canvas course and look at it here. So we would just scroll down, and then we would go to our Chapter 2 module. And then we would look at our Chapter 2 module resources. We would go to Chapter 2 videos to watch. We can scroll down here. And as you can see, there's this particular video here, parallel, perpendicular, or neither, the three cases. If you watch this one, I'll take you through how each one of those particular cases present themselves when you take slope, basically. All right. So, all right, let's go back to our screen here. All right. So let's work this one. All right. All right. So it says decide whether the lines given are parallel, perpendicular, or neither. By the way, a lot of times students try to graph these things, and that is one way to perhaps try to do it. But like when you're trying to do a rough draft of a graph, sometimes they look parallel or they look perpendicular when they're actually not. The most surefire way to determine parallel, perpendicular, or neither is to use the slope formula. As you can clearly see, that's what our objective says here. Use the slopes. So again, what we're doing here, we're using our slope formula here. y2 minus y1 over x2 minus x1. All right. So what we're going to do here, we're going to look at the line that passes through this point right here, negative 2, 5, and 3, 9. And what we're going to do is compare that to the slope of the line that goes through 9, negative 4, and 4, 10, okay? All right, so we're going to calculate slope. So I like to indicate that as m sub 1, because that's my first slope. And then over here, I'm going to find m sub 2. So we'll do 9 minus negative 5, 9 minus negative 5 over 3 minus negative 2. All right, so that becomes 9 plus 5 over 3 plus 2, which is 14 over 5. So we got the slope of that first particular line there. Now we're going to find the slope of this other line. All right, so that would be 10 minus negative 4 over 4 minus 9, which is 10 plus 4 over 4 minus 9 is negative 5. So what we have here is 14 over negative 5, which can be thought in the same way as negative 14 fifths. All right. So here, all right, so they gave us a good one here. All right, remember, parallel lines will have the same slope. These are not the same slopes because we have a positive value and a negative value. So they're not the same slope. So they're not parallel. Then you might think, wait, they're negatives of each other. But remember, to determine if they're perpendicular, not only do they need to be negatives of one another, they need to be reciprocal. So they need to be negative reciprocals, right? So the negative reciprocal of 14/5 would be -5/5. And we don't have that. We got 14/5 and we got -4/5. So what we can say here is there is no relative relationship. There is a relationship. They are opposites of one another, but that doesn't determine parallel, perpendicular, or neither. So since there's no relative relationship, we can say thus they are neither parallel or perpendicular. Right? Neither. Right, so this is the one you don't want to miss. And if you miss this one, I guarantee you afterwards you'll be kicking yourself. Like, oh my gosh, I can't believe I missed that one. But basically we want to write an equation of a line that has a given slope m and the y-intercept 0, b here, right? So notice it doesn't say what particular type or what kind of form of an equation. So we could write it in standard form, or we could write it in the very simple form of y equals mx plus b, which is the slope-intercept form. So let's just write it in slope-intercept form, because this one's really made to order for this particular situation. So all we got to do here is plug in the m and plug in the b. So this is how easy this is. So y equals, and our m is 5, right? So we plugged in the m, and notice that our b, our y-intercept, is 2. And that is all you have to do on that one. That is an equation that satisfies those conditions. All right, so this next problem here, what we're going to do is, the objective, write an equation of a line when we're given 2 points. Okay? When we're given 2 points. So if you look at this problem, we're given 2 points here, 9, 4, and -3, 7. One other thing we want to notice is that this time it wants the equation in standard form. So that is one of the requirements here, is that you do write the equation once you get it in standard form. Okay. All right. All right. So let's just start. Well, I suppose the best place to start here would be ask ourselves, what is standard form? Remember, standard form is ax plus by equals c, right? So that's our standard form, right? That's what we're going for. And also, remember, we talked about a very easy way to get this thing in standard form when we're given a slope and a point. And that is to use the point-slope formula here, which is y minus y1 equals m times x minus x1. The y1 and x1 being the corresponding coordinates of the given point, and then of course the lowercase m being the slope. So when we look at our problem, you might say, hey, there's no slope given there. But remember, we can find the slope here by using our slope formula, right? Remember, our slope formula is m equals y2 minus y1 over x2 minus x1. So the first thing we'll do here is calculate our slope, right? So we're going to have 7 minus 4 in the numerator, and then we will have negative 3 minus 9 in the denominator, which gives us 7 minus 4 is 3. Negative 3 minus 9 is negative 12. That will reduce to negative 1/4. So now we have our slope. And then we might say, hey, to use our point-slope formula, we need, not only do we need slope, we also need a point. They actually give us 2 points. So you could choose either one of those points and plug it into your point-slope formula. The one thing I like to do is to use the one that happens to have both positive values. Put that 9, 4 in there. So it would be y minus 9. All right. So I'm toggling back and forth looking at things, and I messed that up. By the way, let's just say I did that on purpose. Notice that I was actually going to put the x in there for y. That's another common mistake there. So be sure to put in your y coordinate for your y1. So it would actually be y minus 4, right? My y coordinate here. And then my slope is negative 1/4, right? And then my x minus my x coordinate, x minus 9, all right? All right. All right, so, and then there was another thing that I talked about here. When you could go ahead and distribute that negative 1/4 across that binomial there, but I kind of showed you an easy, because what we're going for is standard form, remember? We're going for standard form, and I kind of showed you a trick that'll help you really get it into standard form pretty easily. And remember, that trick was to multiply both sides of the equation by the denominator of your slope, which is 4. So that means I'm going to multiply 4 times y minus 4, and 4 times negative 1/4 is negative 1. We'll just write it as a negative. All right, and as in the next few steps, you'll be able to see how easily this thing will translate if you do it this way into standard form. So now I'm going to distribute that 4, so I get 4y minus 16, and then I'll distribute that negative across the x minus 9, and I get negative x plus 9. All right, so now the only thing I really got to do now is get it into standard form, and that means I move my x's over to the left, and I move my constants, I combine them over there on the right side, which is our c part. So let's add our x. So we're going to get x plus, we'll keep the 4y. Then we will add 16 to both sides. So 16 plus 9 is 25. And there we go. We have our equation in standard form. All right, so we have this next one still in chapter 2. What we have here is a relation that is defining what we want to determine whether or not it does define a function. It is a relationship presented as a set of ordered pairs. Right? And there's this other part on the practice test that asks about domain and range. That's good to do, to just continue to think about domain and range. But on the final exam, it'll just ask you, it'll give you a set of ordered pairs as a relation and ask you, is it a function? So if you look over here, I went ahead and wrote this set of ordered pairs out, right? Because I want to emphasize something about it. Because we're asking ourselves, does this relationship present a function? But if we look at it, we've got 3 ordered pairs here. But notice what we have here is basically a repeating x coordinate of 2, right? That's not necessarily true definition, that is not necessarily a true presentation of the definition of what a function is or is not. But whenever we see this, this is a really good sign that what we're dealing with here is not a function. Okay? Because basically, so we see the repeating 2's, but then we look closer and we see that 2 is not only just associated with 8, but 2 is also associated with 9. And remember, for a function, for a relationship to be a function, each input should only be associated with one output. All right. So this one is not a function. All right, not a function. But one thing, what is going to be a multiple choice question. So what I really do like to emphasize is the language on these things. Okay. So let's scroll up a little bit. We can't really. All right. So since it's not here's the way I usually handle these things. I see that it's not a function. So I'll eliminate the multiple choice answers that say yes, because I know it's not a function. All right. But notice that there's 2 no's here. So what I've got to do is look at these no's and apply the true definition of a function. So I've got to really read carefully here. Notice I've gone ahead and kept the indication from the computer system that B is the correct answer. But let's ask ourselves, why is the C, the other no selection, incorrect? Notice that it says here, each element of the domain, which is our x-coordinate. Remember, a domain is all possible x values or horizontal values, right? Or the first component, right? Notice it says that each value of the first component is distinct and corresponds to exactly one range element, or the second component. Notice it's telling us that each element of the domain distinct and corresponds to exactly one range element. That's not true, because 2, the first component, is associated with more than one second component, 8 and 9. That's why this one here is true. Again, we got to know. Notice this says, because not all of the elements of the domain are distinct and correspond to exactly one range element. Okay. Notice the not there. Be sure to read this very carefully. It's not a really hard thing to do, but you really got to use some reading here. But you really got to use some skills for reading to be sure to get this answer correct. Okay. Let's go back to something here. I want to show you one other thing in this particular example, because it's going to draw on the knowledge that we talked about during the semester. So let's say we were to draw ourselves a very rudimentary x, y plane, or the Cartesian coordinate system here. Well, that would be my y, and that would be my x. So let's graph these points. So we would have we have 2, 8 here. Let's put that right there. And then we got 0, 6. We'll put that right there. So far, so good. But then when we got to plot 2, 9, right? All right. You see what's happening with this, right? If I was to apply the vertical line test here, which remember, when I draw a line on a graph, If it intersects in more than one point, then it is not a function. So this further emphasizes that this is not a function. So there's a couple ways you can look at it. So we're going to look at this one in this particular view right here. By the way, on the practice test, it has this additional thing going on, but like far as the final exam goes, it's just going to ask you, is it a function? Determine whether the relation defines a function. So what we have here is a graph, right? We have a graph. So what we want to do is use the vertical line test. So we draw ourselves a vertical line, and we notice that it intersects at 2 points. So based upon the vertical line test, this is not a function, okay? But what you got to be careful with, again, with these is the language when it comes to describing what a function is. So as I said, you're going to have a multiple choice situation here. So since it's not a function, I know that the yes choices are out. I know the yes choices are out. And notice that A and B really just simply describe the vertical line test. Right? So if you look at this, part B, let's show you the wrong answer. Notice what it says here, the graph of the relation, a vertical line intersects the graph of a relation in no more than 1 point. I'm not a real big fan of that particular situation, but it is intersecting in more than 1 point. It's intersecting in 2 points. So our answer would be A here. Notice it says, it is not a function because at least one vertical line intersects the graph, and as it says right here, more than once. Okay. So that's all there is to that one. All right, so the next one here, and I know that the chapter 2 seems to be going on forever, but this chapter 2 is an essential part for further courses that you'll come across in your college career. But that's why a lot of it is dedicated to this particular chapter. All right, so this next question is going to ask for the domain of a square root function here. Okay, so it's going to ask for the domain of the square root function, and the square root function is one of those two cases that we discussed where there is a restricted domain. Okay, so, and as we talked about in chapter 7, if you attempt to take an even root of a negative number, that is going to be an imaginary number, which we say is not a real number. But functions typically associate themselves with real numbers. And the textbook uses the term a reasonable domain. Okay. So, but this is really not that hard to do, or not really hard to find the domain. I guess the deeper question is, like a lot of times, why are we doing this? Well, we want to know what values are excluded from the domain of a square root function. So, to be able to find which domains are going to be excluded from this particular square root function, what we do is we take the radicand, which remember is the value underneath the radical sign. We take that radicand, and that radicand is 6x plus 3, and we set up an inequality here greater than or equal to 0. Because, as we're said, we don't want to concern ourselves with any negative radicands, because that's an imaginary number, and the textbook uses the term not reasonable, okay? Not a reasonable domain. So all we do here to find the domain is solve this inequality. So we would subtract 3 from both sides, and we would get 6x greater than or equal to -3. Then we would divide by 6 on both sides, and we would get x greater than or equal to -3/6. And that'll reduce to x greater than or equal to -1/2, right? So, but everything we do in this particular class revolves around interval notation. So we got to turn that into interval notation. So it is a greater than or equal to situation. So basically what we have here, and it's a bracket, right? Because it includes the endpoint. And it's greater than, so it goes to the right of -1/2. So in interval notation, this would be bracket -1/2 to infinity. So there is our domain right there, -1/2, bracket -1/2 to infinity. And that's all you got to do on that. Okay. All right, so we finally are to the last question from the final exam that deals with Chapter 2. And so if we look at our objective here, we're going to use function notation to evaluate the function. All right. So what we have here is a function g of z, right? And it's illustrated here, -z² plus 4z plus 8. And what we want to find is g of -5. Remember, what that means is I just plug in the -5 here, okay, and evaluate it. So let's start there here. We are trying to find g of -5, right? So, all right. So remember, there's a trick to this one. There's that pesky leading negative coefficient. So be sure to include that. And then I will plug in -5 here, square it as the function indicates, plus 4 times -5, plugging in -5 for z again, plus 8, right? Okay. So -5 squared is positive 25, but because of PEMDAS, I apply the exponent. Then I apply the negative on the outside. Basically, that's multiplying by a -1. Remember, exponents come before multiplication and division. So we will have -25 here. Okay. And then 4 times -5 is -20. And then we got a plus 8 here. So we'll just kind of evaluate this on out here. -25 minus 20 is -45, and then I add 8 to it, and I end up with -37. So g of -5 is -37. Evaluating a function. All right, so that one takes you through the final exam questions relating to Chapter 2. And there are a lot of Chapter 2 concepts on the final exam. Largely, as I've said before, because this stuff out of Chapter 2 will not go away. It'll show up in a lot of your future college courses in mathematics. Definitely pre-calculus algebra and pre-calculus trig. Statistics goes a little bit into some of this stuff. And even your calculus courses are going to draw on the knowledge that you master in Chapter 2. So you really want to master the stuff from Chapter 2. All right, so you can go on into the next videos, and they'll take us through Chapter 4, 5, and 7.